Hey everyone, thank you for your time today. My name is Eric Merrill. I'm here with Arunima Gupta, and we're here to talk to you about the next generation of financial forecasting. We're leveraging Databricks as the core engine and really the brains behind a solution that we want to take you through today. But more broadly, we want to talk about what's happening in the world of financial forecasting and what capabilities are really new and exciting to help make this more effective, more accurate, and more agile in light of what's going on in the world today. Arunima, why don't you take us to the next page and we can do some quick intros and then dive right into the agenda for today. So as I mentioned, my name is Eric Merrill. I'm a managing director with Deloitte's finance and enterprise performance practice within Deloitte Consulting. I lead our solution development in this area around applying AI, machine learning, and predictive capabilities to finance and helping finance organizations be more effective.
Hi, I am Arunima Gupta. I'm a manager within the artificial intelligence and data engineering practice at Deloitte. My job entails making sense of data. It is identifying AI and ML use cases where I can convert data into actionable insights for the business. So what are we here to discuss today? We'll go through the evolution of financial analytics, on how we've moved from reflective to predictive, and then we'll talk about how PrecisionView accelerates predictive analytics. Then we'll go into some of the use cases of where we've implemented PrecisionView for our clients and what are the benefits that they've gotten out of it. From there, we'll take a deeper dive into the under the hood solution and trying to understand what is PrecisionView and how it is made up of the different architectural components. And then finally, Eric will present PrecisionView in action and with a demo. So why are we talking about financial planning and analytics? It's not a new term, it's been here forever. The reason we're talking about it today is because it's gone significant evolution. We have gone from thinking about reflective to predictive. So what does that mean? If I were to look at reflective, I might see that looking at my data, it seems like product A has been doing great. I might be able to derive some kind of basic analytics from it. Okay, product A was doing great because I spent a ton of advertising dollars on it. As I move towards predictive, I want to see, given the advertising dollars that I'm spending today, what would the sales mix look like in the future? And not just that, it might be other components that I'm not even thinking about. What factors outside of advertising are impacting my sales? And then the final expression of this would be to integrate all different kinds of internal and external factors along with structured and unstructured data to find some signal that informs my decisions in the future. That's why we're talking about predictive analytics, and that's where we start talking about forecasting. Now, forecasting itself has also undergone evolution. While traditional forecasting was focused more on maybe using some kind of simple statistical tools to see my historical trends and forecast that in the future. It's a good enough model if I were to assume that my history is a good indication of what my future looks like. But what if that does not happen? What if my history is very different from the future? Or what if my present is very different from the future? Can you think about a situation where your inflection points in the current world are not something that you would expect to see in the future? Well, I can think of one, our current COVID situation. There are certain trends that might continue, but there are other trends which we won't expect to see in the future, right? So that's where our traditional challenges with financial planning gets exacerbated because of these situations. In these situations, our CFOs would want to do more real-time scenario modeling. We've seen that e-commerce sales have increased during the COVID period because everybody was sitting at home and they were ordering online. Would trends like those remain? Are there certain scenarios that I can play around with and forecast my sales? What happens if the number of pandemic cases continues to increase? How would that impact my sales? What if the pandemic cases decrease? These are the different kind of drivers that I would want to play around with if I were a CFO to try to understand what does my financial organization look like. Eric, have you seen similar examples with some of our clients?
I have, and building on the examples that you were sharing, I think there are a couple of other changes that are impacting finance today as well. Finance is used to operating on a schedule, on a set cycle, and the disruption present in the world today does not really coalesce with that disposition very well at all. In fact, most of the FP&A or finance organizations that I've worked with are scrambling to meet the daily, if not hourly, demands of their CFOs who need to evaluate decisions, need to try to understand what the latest news release or the latest piece of information really could potentially mean for their business and how it might impact their financials and the choices that they make. And so the idea of living in a world where one, trying to understand all the information as it changes in the world around us, distill that down and try to make sense of it, and then try to apply it in a meaningful way to develop updated projections and decision analysis is really too much to ask of humans alone. The good news is there are machine-driven capabilities out there that can help accelerate those tasks and activities and bring additional insight into the process. And I'd say more so than in the last number of years, there's a lot of interest across many of our clients and finance organizations about how to move in that direction and do so in a meaningful and successful way.
Thank you. And one of the ways we are moving in that direction is through driver-based forecasting. So what is driver-based forecasting? I think we alluded to it a little bit in the previous slides. It's trying to look at what are the changes within my organization, which I might refer to as internal drivers, or factors outside of my organizations, maybe macro or microeconomic factors like inflation, fuel rates, etc., that might impact my finances. And bringing all of that into my forecasting methodology to be able to see how all of that impacts my forecast and how sensitive is my forecast to it. So it's not just the impact itself, but how much is it impacting my sales? And this cannot be achieved through traditional methodologies. As you can imagine, with the amount of data that would be required for driver-based forecasting, it would require a lot of space and a lot of computational power. The good news is we have all of that. Technology is not a constraint anymore. Through cloud-based computing, we have all of these facilities available to us. And that is where AI can help. AI would reduce the amount of manual intervention, which frees up resources to do more meaningful insightful work instead of focusing on repeatable things that can be automated. We can also use an unlimited amount of external and internal factors to inform our forecasts, because now we have the ability to do that. And also, we can use several different models. So our organization is very flexible. So our models should be flexible as well. We don't have to focus on just one kind of algorithm. We can use a whole host of algorithms to figure out what my future is going to look like. And these are were some of the fundamentals on which we based PrecisionView. Eric, do you want to talk about PrecisionView now?
Sure, I'd be happy to. Thanks for the great setup. So PrecisionView was really our answer to how do I take those capabilities that Arunima was talking about and actually make them useful. And I don't mean that they're not useful unto themselves, but how do you actually embed them in the ways of working for finance? How do you change how finance goes about its work of running analytics, creating forecasts, so that it's not just a black box. It's not just applying all these advanced capabilities without visibility into what is this, all these different sources of information mean? How do all these different algorithms work? As you might imagine, that could be a daunting undertaking, for your average financial analyst to feel like they need to dive in and understand how all of that works just to complete a forecast. And so we created PrecisionView. And if you think about the problems we were trying to solve, we're trying to provide better connectivity within finance organizations across their different processes. A lot of times when you think about strategic planning, target setting, annual planning, forecasting, those processes can be very disconnected with varying sets of assumptions that don't really connect to one another. Those processes can be inconsistent. The way in which parts of the business create their forecasts can also be very latent and have different levels of quality in terms of what typically goes into them. If that's not aligned to a clear accountability matrix, it can be really challenging to understand who owns what numbers and how are they created and how do they come together. And most organizations are doing their forecasting in Excel. And so while there are some, algorithms in Excel, they're really missing out on amplifying the capability of data science and really embedding it into ways of working. And so what PrecisionView and our approach to implementing PrecisionView has really done is brought statistical models and machine learning into the backbone of that process to really amp up the thinking and automating it as well in terms of what goes into evaluating different inputs, different drivers, history, considering different forward looks and scenarios, and being able to bring that forward in a way that allows you to visualize the outcomes, to be more agile in how you build budgets and forecasts, and be able to really play with different scenario models and outcomes. Because as I mentioned earlier, the finance cycles of old, every 30 days, we're going to go through a forecast process, or every quarter, we're going to go through a forecast process. The demands for that forward look, for those analytics, don't wait anymore. The need to be able to do that on demand is very, very real. And so with PrecisionView, we can drive better collaboration. We can raise the capabilities of all those who are forecasting with a centralized tool set. And then we can give more capacity back to the organization to get into the so what of what do the analytics mean? What do the decision choices really mean to the organization operationally, which is extremely important to connect to the different assumptions and drivers that you may put into the process from a forecasting perspective. There are a couple of key steps in the PrecisionView process. Always comes down to a strong foundation in data and bringing that in an automated and streamlined way. And that can include having to interpolate or extrapolate data, apply data cleansing, all of which can be done in a highly rule-based and or automated way. Then applying predictive and learning analytics, really automating the process of doing things like backtesting, model selection, and creating forward-looking projections and providing them in a way, in a user experience and an interface where your forecast owners can actually interact with them. They can understand the analysis that the machine has done, not just get, hey, the answer is 42, take it and run with it, but be able to really work with and understand the analysis that was done and take it through some scenario modeling, do some risk and opportunity modeling, so that you're able to do that on the fly, not with a latent, let me go run a batch process and come back in 3 days, but really in an on-demand fashion and in a near real-time fashion, understand what are the insights from changing assumptions, from modeling different drivers, creating different market baskets, if you will, to support the potential decisions that we as a business could make, and being able to do that when I need to, not just after we close the books and it's time to do the forecast. And so that accelerated decision-making, that on-demand decision-making is a key part of the solution, being able to tie together data, advanced analytics, and a user experience from a front-end planning and forecasting solution perspective that really drives better decision-making.
Yeah, and on the on-demand side, as I think where Databricks has given us a lot of value, from an architecture standpoint, it helps us scale the solution and also be able to generate real-time insights.
And all of this, as you're mentioning, comes together enabled by this technology and these platforms to help finance bring together all of its work. So before, where we might have a highly segmented, tools fit for purpose, we're now able to bring together a stack that lets us get from the top to the bottom of the financials, tying together P&L, balance sheet, cash flow, diving deep potentially into areas like working capital that we know are incredibly salient pain points for a lot of the organizations that we work with, getting underneath working capital, cash flow forecasting, and being able to connect those dots and really bring three-statement financial perspectives together is another benefit of applying AI and machine learning and all the platforms that we're going to go through as part of the architecture of PrecisionView.
Yep. And this is not a solution that we are just talking about theoretically. We have had the chance to go in and implement PrecisionView at some of our clients, and there are benefits that the clients are seeing today.
And that's a great call out. This isn't just conceptware, right? These are real life applications of where we've been able to help organizations tie together their data, in many cases using the Databricks platform and various different front end planning solutions to accelerate driver analysis, to create multi-year even forecasts with a high degree of accuracy and creating a lot of insight into what is actually driving and moving the needle for many businesses. One such example on the screen is looking at a consumer products, food and beverage company. If we go ahead to the next one, this isn't industry specific. There is another case study for a major health organization where they were really able to accelerate their target setting and top of house perspectives. If you think about kind of the corporate FP&A function or the corporate finance function, really looking to set a baseline or an expectation or a set of assumptions that they want to communicate out to foster productive conversation with various business segments to understand what is truly driving the results in each part of the business. What are the trade-offs, opportunities for investment, and the potential expectations that they could or should have from a return on investment standpoint. The good news is, and I'd say it's consistent across all of the clients we've worked with in this space, given the tool set we're working with, Databricks and other cloud-based planning solutions, the ability to start small, prove the concept, pilot the concept, and then expand is a very real way to deliver value and frankly to gain stakeholder support for this new capability, which is something new and different for a lot of finance organizations and a muscle that they need to learn as they move forward to the next generation of finance and FP&A.
Yep. Now let's get to the part that really interests me, the architecture deep dive. So coming from a data science and data engineering background, this is what really excites me when I look at the architecture diagram and how it all ties together and how we actually get this thing to work. If there are machine learning or machine engineering folks on this, they would see that this is very similar to how you would do any data science problem. We start with the data collection process. In this case, I've divided it into internal data collection and external data collection. Internal data could be anything that is coming from within the organization. So revenue, cost, volume, anything that is part of their existing P&L. And external drivers could also be sitting within the client organization. Maybe they already have it, or we can go out and source it from reliable external sources. So we can get inflation rate, fuel prices, other macroeconomic drivers, basically to get a more holistic view of everything that can impact my P&L. Once the data collection step is done, then I get into the actual data pre-processing steps, and that's where Databricks starts getting involved. We use notebooks within the Databricks environment for all of our data processing till the model preparation stages. So your data pre-processing would include cleaning up the data, making sure that it is in the right frequency, making sure that if there are missing values, they are imputed, and so forth. We will then store it on Delta Lake, which is a great feature that Databricks has to offer. And I would talk about that a little more in detail in just a moment. From the data pre-processing step, then we get into the actual training part. So your training part is, again, similar to any data science problem. We would have the models, which we start with splitting it into the train and test sections. We would train our models on the training data set, and then we would tune it on the validation data set. Once the tuning is done, and by tuning, I just mean that we want to make sure that the model is reacting well to the data I am providing. And the tuning would be an iterative process. As and when I get more data, my model would get tuned more. And then I get into the actual testing part. So the cool thing about PrecisionView is that we are using several different algorithms to create our forecast. The model testing helps me determine which of those algorithms is best suited for which account. And the cool thing is we don't have to have one best algorithm for each and every account. We can have several different. So it's a very dynamic approach to modeling. Once all of that is generated, I have my set of forecasts. I know which one is the best forecast. I will then send it to a financial planning front end. And this is where it starts getting tangible for the end users. My end users, my forecast owners can then go into these financial planning front ends and start playing around with the solution. And I think the biggest value that we get out of Precision View is that they can now start getting involved with driver modeling. We touched upon it a little bit in the previous slide. I'll give another very simple example. So, for example, I have to forecast the cost of producing chocolate. I might want to look into the cost of my raw materials like oil, cocoa, butter, also my labor costs. Now, the model would be able to put all of these drivers into my forecasting solution and be able to generate the forecast. But what happens if, say, the organization has signed a new labor contract? Maybe my costs are changing. And that is something that the machine itself won't be able to determine. So I would need human in the loop, which is my forecast owners, to come in and inform the machine that, say, 2 months down the line, our costs are going to change by 10%. They will put in those values and rerun the model. And in almost real time, they would get results on how that change impact the cost of producing chocolate. So that's the benefit, like that's the overall flow of the solution and what all you can do. Now, see that you can see that there are a lot of components of Databricks that are highlighted here. All of these components together help us scale the solution. It's one thing to be able to implement all of this in a Python notebook in your local system, and a completely different experience when you want to implement all of this globally. So Delta Lakes provide us with data reliability and performance. Because all of this sits within the Databricks environment, the data flow becomes very quick. And also the benefit is that Databricks can be hosted on any of my hyperscalers, AWS, Azure, GCP. So it is very easily implementable across different client technology techs. I covered some of this in the previous slide. So why do we go with Databricks? One of the biggest things is that, again, like it's a unified platform. So I have many different capabilities within this one platform. I have the capability to create a script. I have the capability to auto schedule. I also have the capability to use compute within Databricks. So data engineers, data scientists, data analysts can all work together in this one space. There is a lot of flexibility in the coding environment. Not only can you have scripts in R, Python, Scala, all of those differently, even within the same notebook, you can use these different languages. So within the same notebook, I can have Python and R, which is really cool. And then, like I mentioned earlier, because Databricks is hosted on any of your hyperscalers, it can be scaled pretty dramatically given the amount of data or the computational power that the client needs. Yeah, so I would say that Databricks has been a really good partner in helping us try to forge a path to the future of forecasting. Delta Lake is a really good storage platform within Databricks, which optimizes for transactional data. If I have any database admins listening to this, you would see the acronym ACID. It is extremely important when we have transactional data. It makes sure that there is consistency and reliability in the data. So that's one of the key features that Delta Lake provides. Also, because like I mentioned, we have all of these different capabilities sitting within this one Databricks environment. The ML ops part becomes very simple because now I have data lakes, I have repositories, I have all of this sitting in one environment. So I can track the entire end-to-end life cycle of your machine learning modeling in the same platform. And then now Databricks has also started focusing on auto ML capabilities. So you do still have the ability to write your own custom code on all of the different languages that I was talking about earlier. But if you have more citizen data scientists who are not that interested in writing custom code, or you think that there are existing packages out there that can be used directly, Databricks also offers auto ML capabilities. So that was a lot of talk around Databricks and the architecture. I think it'll be cool to now actually see what Precision View can do.
Thanks, Arunima. Just keeping an eye on the clock, I know we want to make sure that we adhere to the session guidelines. I'll do a quick demo of taking everybody through Precision View. I think we have one example, as we've mentioned, with various hyperscalers as an option, Databricks as a core engine, and then a number of front-end platforms that are usable. I have one in particular, but By no means is PrecisionView constrained to that one particular platform. It's just the one that I'm most comfortable driving. So I'm going to try to, if you can let me share my screen, I'll be happy to take over.
Yep.
And I will present my screen. And hopefully that's visible and we can get started. So PrecisionView has a couple of key components. We're going to go through this pretty quickly. This will be at a quick jog. One is around driver management, and a lot of that analytical horsepower is where we leverage Databricks to execute that code to help execute that part of the process. We have a number of forecast models that we dynamically evaluate and choose based on a set of criteria that are definable by the team in terms of how we want to optimize the forecast. And then I have the ability to run and model multiple scenarios and do some very innovative analytical assessments of the probability of certain outcomes. And so we'll go through this pretty quickly for today. Some key features of the platform we're looking at is the ability to pivot through very easily various different views and pivots and understand what the different forecasts and outcomes look like. That's pretty native to most cloud-based planning platforms these days, but it's a real enabler to bringing the visibility and the insight into the analysis that's done on the back end on the Databricks platform. So within the driver management space, I'm able to look at a combination of internal and external data, look at historical information. If we were to pivot through different selections, you would see the data on the page change. So this is really where the acceleration from platforms like Databricks is a huge win. If I had humans doing this by hand, this would take days, if not weeks, to go through and manually execute all the processes at each intersection that I wanted to be able to evaluate my business. And so you can imagine why that would be a huge barrier to being able to use this type of solution and this type of capability, particularly at scale, where I don't have that issue. I can set different assumptions and put in different guardrails for the different drivers that I'm using. I can even use the platform to help me understand, am I making bad decisions? As a forecast owner, there's a human error element. To us, this is very human plus machine. So I still have the option to test out different combinations and permutations of drivers and assumptions that I want to model. The machine's just going to keep me honest and help me understand, where I may be not looking at the best information or trying to include the best information. But you can see here, I can easily pivot through. I can look at my various drivers. I can set and modify the values for all those drivers very easily. And then I can rerun and remodel all the forecasts as quickly as I need to. So getting to that on-demand insight, understanding what is underlying and driving the different elements I'm trying to predict is hugely helpful to fostering very different and engaging business conversations. Now, if I get past my drivers and get into the modeling world, now I'm looking at a whole bunch of different perspectives. And so, back testing is a very, traditional and widely accepted way to evaluate the quality of the different models that I might be looking at or modeling or considering, I should say, as part of what I want to evaluate from a forecast perspective. This allows me to also apply my business insight. So I have backtesting insight in terms of what models have best fit history, but as Arunima mentioned earlier, maybe history is not always going to be the best predictor. We get a lot of insight into patterns, into how the business moves, but what if the business is going to move differently? Or if I have insight that lets me know that it might be shifting or changing in how we want to look at things going forward, I can actually review all these different outputs, understand how well they reflect what has happened historically, but also make conscious decisions to provide a different baseline or a different starting point for my corporate team, for my business segments as they go about looking to create their forecast. And I can actually help them see and understand the difference between maybe what based on history was the best indicator or the best selected model versus what I'm choosing based on the shape of the curves that I'm looking for, versus even just baseline adjustments. Someone is obviously being very optimistic here about what they think is going to happen in the upcoming quarter. I have the ability to annotate and comment on things as well, which is incredibly helpful. Ultimately, I'm going to lock that forecast and carry it forward into my process. Now, point estimates are really a terrible and challenging thing when you're thinking about performance management and measurement. And so while I have my selected model from the output from the engine, I also have a confidence interval or a predictive interval around that estimate. So I can understand some elements of like sensitivity and how precise do I really think that number is. I can compare and stack that against plan, and I can even set thresholds of acceptable variance. So we're now kind of moving from the highly analytical, automated application of AI and machine learning and starting to see how it can embed into the ways of working and the processes that are typically managed and driven by humans from a finance forecast process. And you can see how I can stack up different alerts and different variance calculations around this. Ultimately, what we're trying to get to, in my mind, is being able to compare and contrast and walk forward between multiple scenarios. And so what you see here is I have my baseline machine-driven forecast, but leveraging those relationships, those coefficients, those driver market baskets and how they connect to what we're trying to forecast, I have the ability to see and stack that against alternate sets of assumptions. Now, in today's exercise, we're not going to go through all the drivers and assumptions that impact, COVID economic case one, but you can see how easily I can compare and contrast against a baseline model. I can walk through in a very granular way, if that's interesting. I can easily stack comparisons of what I want to look at and pivot back and forth through looking at forecast, comparison scenarios, prior quarter, same quarter last year. I can stack my variance calculations. And I can even come down here and across my different scenarios, I can break this down by line item and understand the different perspectives. And so being able to do that and manage that in a very connected, integrated way, being able to rerun and reanalyze some of these relationships, whether it's on a quarter by quarter, month by month, week by week, day by day basis, being able to do that in a platform is an incredible time savings and brings a lot more insight into the process than would otherwise be available. I also have the ability, if I want to do some probabilistic testing, to even see, how likely is the outcome that I've chosen to really occur. You could use this for project level forecasting as another use case. You could also use this to evaluate the likelihood of the various scenarios based on historical data and projected outcomes that you may have available. So the key here is really, as we've been saying all along, is being able to stack things up and bring them forward in a way that it's not just here's the answer. It's very much driven with an interest in gaining insight and really understanding, one, the increased capability of the analytics that are available, two, being able to make that transparent, and three, being able to have a very different business conversation because you're not spending all your time defining relationships and cranking through numbers. You're actually able to model the different scenarios and assumptions and different potential outcomes that might be possible, and very quickly see the results and stack and compare and contrast and really dig into the insights underneath. So I won't spend any more time today on a demo. This was just a quick flavor. I think we've got one or two things to close out with, and then we'll let everybody go on to the rest of their day.
Thanks, Eric. I think that was the meat of the session, actually being able to see what the forecasts can do.
I would agree. I think the one point we probably want to hammer home, and we alluded to it a little bit during the demo, is that the idea here is that the machines and the artificial intelligence can really amplify and accelerate the time to insight. And also time to deeper insight becomes greatly reduced as well. So many finance organizations feel like they don't have the time to analyze the numbers because it's so hard just to get them together or just to get alignment on a forecast that gets created. Which is typically a point estimate and doesn't necessarily have the robust nature of ranges and confidence intervals and probabilistic testing associated with them. But ultimately, you can't forego the human intelligence aspect. Models will only be as good as history and the insight that they're able to collect from the data provided to them, and the criteria set for how they filter and make decisions against that data is really as good as they can be. And so there's definitely a role. This does not replace the humans. It's allow the humans to focus on that real insight, that real business intelligence, that human intelligence that isn't going to be available anywhere else. It's the gut feels, it's the conversation with the customer, it's the knowledge of a new product launch and certain decisions that are being made as part of that maybe can't be codified or captured in data explicitly until it happens. And so it's really important to think about embedding these capabilities and leveraging these technology platforms like Databricks and the other components of the solution of PrecisionView to think about how you're going to change the way people work and make sure that their role in the process is really clear. I don't know, Arnim, if you have any parting thoughts, please feel free to layer on, but this to me is one of the most exciting areas to focus on today.
Yeah, absolutely. The job of the machine is to take away all of the boring, mundane stuff so humans can focus on the fun part of actually creating direction. The machine is telling you this is what this is what your history and your data is telling us. This is what the forecast looks like. Now, what you do with the forecast and how are that informing the directions that your organization takes is up to you. And we hope that it frees up time for you to do all of that fun stuff. And with that, I think we can call it a close.
Yeah, thank you everyone for the time and attention today. Thank you, Databricks, for the opportunity to present as part of the conference. And we look forward to talking to anyone interested in the topic sometime soon.
Thank you all.